What's going on, everybody? Welcome back to my YouTube channel where we have this nice and beautiful Olympiad question on the board that we're going to be solving. And the question says, find all values of x for which x to the power of 3 minus x minus 1 all raised to power 2 is equal to 23. Well, our first step towards solving this question will be for us to simplify this 23. Now, I have a cube here, which means this is a perfect cube, and I have a square here, which means this x minus 1 is a perfect square. So I'm going to be simplifying 23 such that it has a perfect cube and a perfect square. So let's go ahead and do that. So we have x cubed minus x minus 1 raised to the power of 2 is equal to, now 23 can be written as 27, which is a perfect cube, minus 4, which is a perfect square. So 27 minus 4 is the same thing as 23. So let's go ahead and simplify. So we have x cubed minus x minus 1 squared is equal to, now 3 to the power 3 is 27 minus 2 to the power 2 is 4. Our next step will be for us to move 3 cubed to the left hand side. And when I do that, I'm going to be having x cubed. As 3 cubed crosses to the left, it becomes minus 3 cubed equal to, I'm going to be moving negative x minus 1 all raised to power 2 to the right hand side. And when I do that, it's going to become positive. So it becomes x minus 1 raised to power 2. I've already got minus 2 to power 2 here. Now notice that I have difference of 2 cubes on the left hand side and I have difference of 2 squares on the right hand side. So let's go ahead and simplify these expressions. For difference of 2 cubes, this can be written as x minus 3 times x squared plus 3x and now plus 9 equal to, for this expression, I'm going to be having x minus 1 minus 2 times x minus 1 and then plus 2. So this is the difference of 2 squares that we've expressed. So now let's go ahead and simplify what we have on the right hand side. So we have x minus 3 times x squared plus 3x plus 9 to be equal to x. Now minus 1 minus 2, that's minus 3 times x. Now minus 1 plus 2, I'm going to be having plus 1. Now notice that I have x minus 3 on the left and I also have x minus 3 on the right. So I have two cases here which I can say x minus 3 is equal to 0, or this expression on the left, which is x squared plus 3x plus 9 is equal to this other expression on the right, which is x plus 1. So these are the two cases that I have. So for the first case, you notice that x will be equal to 3. This happens when you move negative 3 to the right hand side. Now, what about the second case? Let's go ahead and simplify the second case. I'm going to be moving what I have on the right to the left hand side so that I have x squared plus 3x plus 9. Now, when x plus 1 moves to the left, it becomes minus x minus 1 equal to 0. So this becomes x squared. Now 3x minus x, I'm going to be having 2x. Now 9 minus 1, I'm going to be having 8 equal to 0. So we have a quadratic equation which we're going to be using the general formula to solve. So from this quadratic equation, we have the a to be 1, b to be 2, and c to be 8. So let's go ahead and substitute into this quadratic formula, which is very familiar to us. b squared minus 4ac all over 2a. Let's do that in the next slide. So on substituting, I'm going to have x to be equal to negative b is 2, plus or minus the square root of b squared, that's 2 squared, minus 4 times a. What is a? A is 1, times c is 8, all over 2 times a, that's 2 times 1. So x will be equal to negative 2 plus or minus the square root of, now 2 squared is 4, minus 4 times 1 times 8, I'm going to be having 32, all over 2 times 1, 2 times 1 is 2. So on simplifying further, you notice that the value for x will be equal to negative 2 plus or minus the square root of, now 4 minus 32, I'm going to be having negative 28 all over 2. So I have a complex value here. So let's go ahead and simplify this complex value. So this becomes x to be equal to negative 2 plus or minus. Now this expression can be written as 28 times the square root of negative 1 all over 2. So x will be equal to negative 2 plus or minus. Now the square root of 28 is 4 times 7. And 4 is a perfect square. So the square root of 4 is 2. But 7 is not a perfect square, so it remains inside of the square root. And now look at the square root of negative 1. The square root of negative 1 is I all over 2. Now we have 2 to be common in the numerator, so let's go ahead and factor 2 out. So bringing out 2, we have negative 1 plus or minus the square root of 7 times I all over 2. Now notice that 2 can cancel off, so that we have x to be equal to negative 1 plus or minus the square root of 7 times I. So we have two values for x here, which is x is equal to negative 1. Taking the positive side, we have plus the square root of 7i, or x is equal to negative 1. And now this time, taking the negative, minus the square root of 7i. So we have three values for x. We have x to be equal to 3. That's the first value we have. That's the first value for x. There's a second value for x, and this is the third value for x. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.